Hi, grade 6. Today we will take the second lesson, which is called the law of levers. We finished the first lesson, types of levers, and today we want to know what is the law of levers. We took in the previous lesson that any lever is a rigid bar that rotates around a fixed point called fulcrum and is affected by an effort force and resistance force. The symbol of fulcrum, O, the symbol of the effort force, capital F, and the symbol of the resistance force, capital R. The mathematical equation that explains the relation between the effort force and the resistance force is called the law of levers. So, the law of levers states that the effort force times its arm equal the resistance force times its arm. We don't know what is the effort force arm, and we don't know what is the resistance arm. If you want to know the force arm or the effort force arm, it's the distance between the effort force and the fulcrum. And the resistance arm is the distance between the resistance force and the fulcrum. So, the distance between the effort force and the fulcrum is called effort force arm. And the distance between the resistance force and the fulcrum is called resistance arm. When the force arm and the resistance arm are equal in length, this lever doesn't conserve any effort. يعني مش بيحافظ على مجهودنا، بيخلينا ما نرتاحش. So, when the force arm and the resistance arm are equal, we can say that this lever doesn't conserve effort. I want you also to know when the force arm is shorter than the resistance arm, like this shape, the length of the force arm shorter than the resistance arm, the length of the resistance arm. In this case also, this lever doesn't conserve effort. So, there are two cases in the levers. We can say about these levers that they don't conserve our efforts. When the effort force arm equal to the resistance force arm, and when the effort force arm is shorter than the resistance arm. In both two cases, I can say that the lever doesn't conserve effort. Okay, when the force arm is longer than the resistance arm, does this lever conserve the effort? Yes. In this case, in only this case, the lever conserves the effort. When the effort force arm is longer than the resistance arm. Okay, if I have a lever, in this lever the force with a value equal 50 Newton. It is the force, the effort force, 50 Newton. Affects a lever of the second class lever that is its force arm 20 centimeter. So I have here the force, the effort force 50 Newton and the effort force arm 20 centimeter. Calculate the resistance force where the resistance arm is 5 centimeter. So I have here three numbers. The effort force 50 Newton, the effort force arm 20 centimeter, and the resistance arm 5 centimeter. And he wants me to calculate the resistance force. First of all, I must write the law of the lever. Effort force times its arm equal resistance force times its arm. And I must put the numbers under each one. Effort force 50 Its arm means the effort force arm. It's 20 centimeter. The resistance force, I don't know. He wants me to calculate it. Times its arm, which is the resistance arm, equal 5 centimeter. So 50 times 20 equal resistance force times 5. If I want to calculate the resistance force, I'll make 50 times 20 over 5, divided by 5, equal 200 Newton. Be careful, the effort force and the resistance force, their units, Newton. Their units, Newton. What about the arm? Effort force arm or resistance force arm, both of them centimeter or meter. Their units, centimeter or meter. Let's talk about the law of levers and conservation of efforts. Some types of levers conserve effort. As we said before, they conserve effort in two cases. In one case, when the effort force arm is longer than the resistance force arm. In only this case, this lever conserves the effort. While some other types of levers don't conserve effort. And we said also before, when the force arm and the resistance arm are equal, the lever doesn't conserve effort. And also when the effort force arm shorter than the resistance arm, also this lever doesn't conserve effort. What the meaning of doesn't conserve effort? Yani this lever has no any mechanical benefits. It makes me tired when I'm using it. Okay? What about conserving effort? Conserving effort, so it has a mechanical benefit. By applying the law of levers on the three types of levers, we can find that in the first class levers, there are three possibilities in this type of levers. There are three cases in the first class levers. Number one, if the force arm is shorter than the resistance arm. We know that the first class lever, it's the lever in which the fulcrum in the middle between the effort force and the resistance force. Maybe the force arm is shorter than the resistance arm, like case number A. In this case, the result will be that the effort force will be larger than the resistance force. So, when the effort force arm shorter than the resistance arm, the effort force becomes larger than the resistance force. So, the force which I'm doing with my hand, which is getting out from my hands, is more than the object which I wanted to cut, which I want to break, which I want to move. So in this case, the lever doesn't conserve my effort, so it has no mechanical benefits. This is case number one in the first class lever, but it doesn't conserve effort. للأسف case number one ديت doesn't conserve my effort. So let's talk about case number B in also the first class lever. In case number B, the force arm is equal to the resistance arm. يعني الفulcrum in the middle, midpoint between the force arm, the force and the resistance. For that, the force arm is equal in length with the resistance arm. Also, in this case, the effort force become equal to the resistance force, so also it doesn't conserve my effort. So, in case number A and case number B, the levers that don't conserve my effort. What about case number C? If the force arm longer than the resistance arm, in only this case, the effort force becomes smaller than the resistance force. And also, in this case only, the lever conserves or saves my effort, so it has a mechanical benefit. So in the first class lever, we have 3 cases. 2 of them don't conserve our efforts, and only one conserve the effort. In case number A and number B, case number A, when the effort force arm shorter than the resistance arm, and case number B, when the force arm and the resistance arm, both of them are equal. In these 2 cases, the lever doesn't conserve my effort. Because in case number A, the effort force is larger than the resistant force. In case number B, the effort force equal to the resistant force. What about case number C? It's the only one in the first class lever which I can say that they conserve my effort. When the effort force arm longer than the resistance arm. In this case, the effort force becomes smaller than the resistance force. What the meaning of this? The meaning of this is that the force which is getting out from my hand, which I make with myself or with my hand, is smaller than the task I want to do, that such as breaking anything or cutting or moving any object. Okay? So in the first class lever, we have only one case which save the effort and has a mechanical benefits, and the 2 other cases, they don't save the effort or don't have a mechanical benefit. What about the second class lever? We know that the second class lever is the lever in which the resistance force in the middle between fulcrum and effort force. We took that before. Here, if you look to the drawing here, we will find that the effort force arm always longer than the resistance arm. Always. The force arm longer than the resistance arm. So, always the effort force is smaller than the resistance force. So in the second class lever, this type of levers always conserve the effort or save the effort or have the mechanical benefits. So all the examples of the second class levers, we will find that they conserve our efforts and save our efforts. Why? Because in this type of levers, the force arm longer than the resistance arm, and so the effort force smaller than the resistance force. What about the third class lever? The third class lever, this type of levers, we know before that it's the lever in which the effort force in the middle between the fulcrum and the resistance force. Look at this drawing. Always we will find that the force arm is shorter than the resistance arm. So when the force arm shorter than the resistance arm, so the effort force always larger than the resistance. So this type of levers don't conserve effort. They have no mechanical benefits. Why? Because the force arm is always shorter than the resistance arm, so the force is always larger than the resistance force. But all the third class levers and some of the first class levers that don't save effort and have no mechanical benefits, but they are beneficial in other things. مش معنى انه some types some examples يعني in the first class lever and all the examples of the third class levers don't conserve effort يعني نرميهم. No, لا. We can use them in other functions. They are also important in other functions, such as increasing distance, avoid dangers, increasing speed, accuracy in performance. Think with me. Who can think about example in increasing the distance in the third class level? Yes, the manual broom. It's example in the third class level and used in the increasing distance. What about avoid dangers? Who can think about example? Excellent. The coal holder in the third class level. طب increasing speed? Yes, the hockey pad in the third class level also. What about accuracy in performance? Yes, the tweezers in the third class level. They all in the third class levels, and we know that the third class levels don't conserve effort, but they are important in other things. A lot of things they important. Increasing distance, increasing speed, avoid dangers, accuracy in performance. Although they don't conserve effort, but they are also very important. Give reason. Sometimes the first class level save effort. So he wants you to talk about the case in the first class level in which the lever conserve effort. When the force arm is longer than the resistance arm. يبقى هتقول له because sometimes in the first class level the force arm longer than the resistance arm. So the effort force is smaller than the resistance force, so conserve the effort. Another give reason. The nutcracker and the wheelbarrow save effort or have mechanical benefits. You can say because the force arm is always longer than the resistance arm. So the effort force always smaller than the resistance force. Here he is talking about the nutcracker. Nutcracker in the second class level. Example of the second class level, and also the wheelbarrow. So he is asking you about the second class level. And you know that in the second class level, always the force arm longer than the resistance arm. And so the force is smaller than the resistance force. And when the effort force is always smaller than the resistance force, so these levers conserve the effort or have mechanical benefits. Let's do a comparison between the three types of levers. First class lever, second class lever, third class lever. What about the location of the fulcrum and the effort force and the resistance force? Of course, you know that the first class lever, the fulcrum, in the middle between the effort force and the resistance force. In the second class lever, the resistance in the middle between fulcrum and the effort force. In the third class level, the effort force in the middle between the resistance force and the fulcrum. What about the effort force arm and the resistance arm? In the first class level, the force arm may be longer or shorter or equal to the resistance arm. May be longer than, shorter than, or equal to the resistance arm. There are three cases in the first class level. What about the second class level? No, it's only one case. Always the force arm is longer than the resistance arm. In the third class level, also only one case. Always the force arm shorter than the resistance arm. So, what about saving effort? We can say in the first class level, sometimes it conserves the effort or save the effort. Sometimes. Because some of them save effort, but the others don't. What about the second class level? They always save the effort. What about the third class level? They always don't conserve the effort. They always don't save the effort. What about the benefits? First class level, some of them have a mechanical benefits, but the other have other benefits as increasing speed, increasing distance, avoid dangers, and accuracy in performance. In the second class level, all of them have a mechanical benefit because all of them save effort. What about the third class lever? Although they don't save effort, but they are used in increasing speed, increasing distance, and they are used to avoid dangers, accuracy in performance. So they have also a lot of benefits. I want you to study this lesson well. I hope you understand it. After you studying the lesson, I want you to try to answer worksheet number 2 by yourself. Goodbye, study well, and in the next video we will answer worksheet number 2 together. Goodbye.